Hi everyone, it's Mr. Slomka, and I wanted to talk to you about section 8.5, which is on recursive rules. Recursive rules is a very, very straightforward section, and it's going to work out really, really nicely for you. And one of the things that makes it so great is because this is already the way that probably a lot of you are already thinking about these problems. So it's very, very nice. The notation is a bit tricky, and so I want to make sure you're clear on that before we end our lesson today. But other than that, it's going to be very, very great. Okay, so now, before we talk about these recursive rules, I want to point something out to you. So recursive rules are for sequences. And so now if you're thinking to yourself, well, we already know about sequence rules, Mr. Slomka, you're right. You do. You have some really, really great sequence rules already. And so those rules have a name. Those are the arithmetic rule, sequence rule, and the geometric sequence rule are going to be called explicit rules. And the reason for that is because the variable that exists in those rules is going to be n. And n represents a term's number or a term's location. You take that n value, you plug it in, and then you get the term itself. The way a recursive rule works is different. And the way that a recursive rule works is that what you're going to do in order to get your term is you're going to need to know what the previous term was. So that is slightly different. And so I want to point out those strengths and those weaknesses to you so that you understand them as clearly as possible. So let's get started. So the first thing I wanted to talk to you about was just a quick little review right here. Arithmetics and geometrics are some terms that have been flying around recently, but I want to make sure that you're clear on them. Arithmetic, the major thing I need you to remember is that it has to do with a common difference, which means addition or subtraction. Common ratio for the geometrics means that we're going to be talking about multiplication or division. Okay, so now let's see if we can take a look at a couple of recursives. So here are two recursive problems and some very clear directions that are super, super popular. Some things I'd like you to notice is that they have these big brackets, and then inside the brackets we've got two facts. So a recursive rule is a bit bigger than usual. Now the first fact in the recursive rule is going to be kind of like a gimme. It's going to be given information that you can use. You don't have to work on it at all. You're just going to put it to work. So the question is asking us to write the first 5 terms in the sequence. And right here, what they're going to tell you is that A naught, otherwise known as the initial A value, is 3. So that's kind of like your very first term. That 3 is going to be part of our answer. And we don't have to do any work for it. We're just going to write it down. Okay, next. Next, what we want to do now is we want to calculate the next term in the sequence right here. In order to get that guy, you will have to do some work. So we're going to drop down from the first line of text down to the second line of text in the brackets. And so this is where we're going to get this tricky notation right here. So this tricky notation is an minus 1. And as I already showed you, what an minus 1 means previous term. So this is strange because a lot of times people see minus 1, and what they want to do is they want to reach for their calculator and they're going to type in minus 1. That's a bad idea. What that minus 1 really means is it means go back 1 spot. So if you want this term right here, where you're going to have to do is you're going to have to go back 1 spot to this guy right here, which is the previous term. When you go back 1 spot, you're going to add 7 to it. So to get this term right here, we're not going to use the number 1. What we're going to do is we're going to go back 1 spot, and we're going to add 7 to it. 3 plus 7. Let's do it again. So now right here for the second one, what we want to do is we're going to use our rule again. This guy means go back 1 spot, so we're going to go back to the 10. And what we're going to do with it once we go back 1 spot is we're going to add 7. So this is interesting. I want you to notice that I have not subtracted 1 a single time. I didn't do 10 minus 1 to get 9 and then add 7 after that. No, 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 no. That 1, once again, means go back 1 spot. Let's do the third term. So the 13 means I'm going to go back to the 17, and I'm going to add 7 to that. And the fourth term means I'm going to go back to the 24, and I'm going to add 7 to that. That's it. It's supposed to be very, very simple and very, very straightforward. It shouldn't hurt too much. In fact, I want to show you that your calculator is actually really great at doing this as well. If you're using a calculator, it could be a graphing one or a scientific one, what you can do here is you can very quickly and easily take that number and you can plug it in. Now, the thing that we're supposed to be doing right here is we are supposed to be adding 7. That's our pattern. That's the thing that helps you move from one term to the next. So if you simply hit the plus key and the 7, it's going to take your previous answer, which was 3, and it's going to add 7. And that's how you get your 10. Now watch this. If you hit it again, it's going to take that 10 and it's going to add 7. And if you hit it again, it'll do the 24. And again for the 31. And you can keep going through your recursive formula, and then your calculator will keep on spitting out all of the numbers in the sequence. It's a great thing. Your calculator is set up to work on recursives, and maybe you are as well. Maybe when you look at the numbers 3, 10, 17, 24, 31, you can just see very quickly, oh, I just add 7 to get from one term to the next term. And if you do see that, that's so good for you. Your brain is set up for recursives as well. Let's do another one. So now this other one right here is once again going to start off with your gimme, which is -4. Then our pattern here says that you need to start with a 2 this time. So we're starting with a 2, and you're going to multiply by, go back to the previous term. So we're going to take our 2, and we're going to multiply it by whatever we see above it. And that's going to give us our next term. We're going to do it again. We're going to take our 2, and we're going to multiply it by whatever we see right above it. And when you do that, you're going to end up with your next term. Let's do it again. We're going to take a 2, and we're going to multiply it by the previous term. And let's do it one more time. We're supposed to get 5 terms in total. And so this is going to be our 5th term. It's only called A4 because one of our terms was A0. But that is okay. There just needs to be 5 digits that we've written down. 1 that was given to us and 4 that we've calculated. Super. Once again, if you're using your calculator, you can do this very quickly. There is your -4 right there. And then if you just hit ×2, it'll start spitting out the numbers that you need because the calculator thinks in a recursive way. So that's great. Okay, let's work backwards. So now what I have right down here is I've got 2 things for you. I have got a couple of recursive formulas, and I've got a couple of problems where I'm going to ask you to write a recursive formula or a recursive rule. Now these recursive rules are super, super simple. Once again, you're going to start off with a gimme or a given value, and usually it's the first term. Then, for your arithmetics, please remember that arithmetic means common difference, so you want to add or subtract your common difference, which is what we're going to do right here. We're always going to have an minus 1 as part of our recursive rule. That's one of the ways you know it's a recursive. For our geometric, geometrics means common ratio, so we're going to use multiplication and division right here, and we're going to multiply by the previous term. All right, let's try it. So the first thing that we're going to do is we're going to do something similar to what we had done in section 8.3. We're going to have to make the choice as to whether it's arithmetic, geometric, or neither. So when you're looking at these, some of you might just be able to tell. You might be able to jump very quickly from one term to the next. If you're like me, that doesn't happen as quickly, and you might need to use my tricks that I had shown you with a little bit of division or subtraction. In this case, the division works better. 2 divided by 4 is going to be 1/2, and 4 divided by 8 is 1/2, and 8 divided by 16 is 1/2, and 16 divided by 32 is 1/2. It's the same one every time. We use division, and that makes it geometric. Okay, now for our rule. Now the rules, I think it's very, very important that you put your bracket on there. So please make sure you put your bracket. It is a grouping symbol, and it shows that these two pieces are grouped together, not just randomly sitting next to each other. The thing that you want to give right up here is going to be the first term. Now our first term is this 32 right here, and I want you to notice that it is actually A1. It's not A0 like it was at the top of the page. And that's because we don't know what the 0th term was. We just know what our first term is. Now down here, because it's a geometric, we want to write our ratio in. And our ratio was actually given to us by doing this work. We know that our ratio is 1/2. Each number is half as large as the number before it. And then you're going to use your variable, which in this case is an minus 1. You can put some parentheses around it if you'd like, but you don't have to. There's your rule right there. Okay, let's do it 2 more times. For problem number 4, we've got these numbers, and they are increasing in size, but at very different rates. The jump from 1 to 3 is different than the jump from 3 to 4, and the jump from 4 to 7 is different from the jump from 7 to 11, so they're not really working well. If you try the division, you do not get the same answer every time. And if you try subtraction, you do not get the same answer every time. This one is a neither. It's a goofy little set of numbers, and they don't really look like they follow a pattern, and that's because they don't. Let's do number 5. So for problem number 5, once again, some of you might just be able to spot it. If you're looking at this, what you might notice is the numbers are once again increasing, but they seem to be increasing by a much more consistent value. The value that they're increasing by each time is going to be a value of 6. If you don't see that 6 right off the bat, then you can do your subtraction. 27 minus 21 is 6, and 21 minus 15 is 6, 15 minus 9 is 6, and 9 minus 3 is 6. Because we use subtraction that time, that makes this one an arithmetic. For your arithmetic recursive rule, you want to start off with the first given term, which is a 3. Then, for your rule, what you want to do is you want to start with your variable an minus 1, and you want to add onto it, because we're talking about addition and subtraction, you want to add on your difference value that we had here, which is 6. So there's your rule right there. Okay, there's 2 you-try problems down at the bottom of the page, and I'd like you to give those a shot now. Please pause your video, and then I'll put the answers up in a couple seconds. There you go. Those are the answers for your you-try problems. The second one is a little bit interesting because take a look. There is 2 things that are happening to an minus 1, and you must follow the order of operations. So we're going to take our an minus 1 and we're going to square it each time, and then we'll add 4 after that. So that's a little bit interesting. This is going to be video 1 of 2. I'll post another video about the same topic that covers the backside of the note sheet. Thank you so much.